All right. So far, we have pre-processed the data, trained a machine learning algorithm, and fine-tuned it a bit. In this lesson, we will explore the next step, how to deploy it. As suggested in the previous lecture, deploying a model consists in making it available and ready to use. Generally, it consists of two steps, saving the model and then applying it to new data. Okay, we already saved the model in our previous lesson. Hence, here we can move on to the second step of its deployment. It is about creating a mechanism to load the saved model and make predictions, which is our number one priority. Generally, there are two approaches we can take, a clumsy and a clever one. The clumsy approach is the first that comes to mind. We can take all the code we've written so far and execute it, this time feeding it with new data. As you can imagine, this would involve many setbacks and errors of all kinds, syntactic, statistical, and logical. However, with a bit of effort, one could manage to cope. But we'd rather employ the clever approach, wouldn't we? Yes. In practice, we'd prefer creating a module. And why would we want to do that? Because storing code in a module will allow us to reuse it without trouble. In essence, we will treat the methods in this module in the same way we treat the NumPy, sklearn, and pandas methods. Okay, great! Let's check out the module we've prepared and quickly go through it. The so-called absenteeism module is nothing but a pile of code. It contains all our pre-processing and machine learning in one clean notebook. Given that Python is an object-oriented programming language, everything is organized in classes. At the beginning of the file, we import all libraries needed. Then, we define the custom scalar class. It is no different than the one used in the lectures. So far, so good. Finally, we've got the absenteeism model class. That's the only new chunk of code for you. It consists of 5 methods: init, load and clean data, predicted probability, predicted output category, and predicted outputs. If you've encountered object-oriented programming before, you will know that init is the constructor. When we create an instance of a class, it initializes the attributes of that class. In our case, to create an instance of absenteeism model class, there are 2 required arguments, the model file and the scalar file we created in the previous lecture. If they are correctly specified, init will unpickle them and load the model information into the variable reg and the scalar file into the variable scalar. Okay, what else do we have? Load and clean data takes a CSV as an argument and pre-processes the data in the same way we did for the training part. Normally, pass the data through this method to pre-process it. If you take a closer look, you will quickly realize we've placed an optimized version of the same code written in the past 2 hours. However, there are 3 more methods that are similarly written. We will explore those in our next lessons and exercises. Before proceeding with the next video, though, let's first save this notebook as a .py file. In Jupyter, that's done in the following way: File, Download as, Python.py. Google Chrome prompts me that this file may be harmful, but I will keep it anyway, since I've written it and know perfectly well what it does. The result is a new file containing all the code from the notebook, but in .py format. This is called a module. In the next lecture, we will continue by importing and using the functions written in this module in a new notebook file and with new data. Thanks for watching.